All right, so I have the stream going. It was some problems with the resolution, but it's going. So first things first. The course has multiple parts. So one of the parts is related to infrastructure and architecture of the cloud services. So mostly Christopher is doing that. Part of it is related to using the web services or cloud services, combining them and doing some things with them. So we will be doing both. And part of the course is related to programming. Roughly 1/3 you will have to program in Go. So how many of you had Go before or played with Go at home? Okay, not many people, some. So it's a new programming language which we will kind of learn in this course, and we will use it for doing all the assignments. Some people who finished this course, they switched to Go and they did a lot of work afterwards. I'm working with a master student who finished the bachelor degree, and he said that after he learned Go, he kind of did everything in Go for web applications and for whatever he wanted to do. So it is kind of an easy language to pick up, and it's easy language to use. So we will do a little bit of a discussion today on that language. I have to do a little bit of a check. So how many of you used Git? Is there anybody who didn't use Git? No.
So like now or like have used before?
Like before.
Okay.
Yeah. Good. So we will be using Git version control in this course. Even if you're doing a project alone, it's good to use version control because it kind of helps you to roll back some of the changes that you do, experiment with some features in a branch, and so on. So even if you're doing project without a group, it's a good idea to use version control. So what sort of IDE or editors do you use for programming? Yep. Visual Studio. Yeah. Exactly. So we don't care, right? You use whatever you used before. Visual Studio Code has very good support for Go. IntelliJ tools have very good support for Go. There is a special IDE designed for Go, which is called Golang from JetBrains. If you're using NTNU email address and register with JetBrains, you have the ultimate versions of the IDEs. So pick one, the one it suits you, and use it. For some of the demonstrations in the class, I'm using Vim just because it's simple editor. I don't need any fancy IDE. So for those of you who are using Vim, there are some instructions of how to configure it for Go. I did record some instructions of how to configure IntelliJ for Go, but it was last year. This year, of course, things changed. Some package names might be slightly different, so just watch the video if you need to, but it's pretty straightforward to set it up, right? So I'm not gonna show you how to do that, just do it. If you have trouble, then ask me or Yona, and then we will help you, but it should be no problem. So I'm streaming this this lecture, but I did already this lecture like twice in 2017 and 18, so you can watch the previous versions as well. What we want is, I don't want to repeat myself. I just want you to do a little bit more practical things. So what we will do, we will spend the first half of the class me talking about the language and talking about some of the things, and then we will do some programming tasks. And in previous years, I tend to do them kind of on a computer, but this year I will try for you to do them, and then if you have trouble, then we will help you. We will talk about it. So I have some tasks in the slides. Whoops, wrong screen. Yeah, by the way, you don't see the slide, sorry. Can you turn the screen on?
Just around off on the back side.
So the slides and the lectures are already on the wiki. So check it out. I did combine all the simple exercises which we were supposed to do today and tomorrow into a separate page, which says Go Programming Tasks 1. And it has a list of like simple tasks to do in Go or in Go and C++. So for the course, we're gonna use just Go. But for you to kind of appreciate some of the features or some of the design decisions about Go, if you want, you can implement it in C++ as well. Those simple tasks are very trivial. So it should take you no much time to kind of do them both in Go and in C++. And then you can compare which one was easier to express and so on, right? So I kind of have that list here. And yeah, let's move on with the lecture. So all right, so I have to kind of kickstart the class. I have a short video. So let me pause the stream for a moment. Started back. All right. So that was a little bit of a motivational sort of introduction to why we teach programming and why we focus on programming. And it's both the programming from the technology point of view, but also from achieving the effects that you need. You're doing kind of a programming like when you're designing games as well. As a game designer, you try to kind of create a certain effects in the user. And that's also programming, even though you're not actually writing code, you're doing a game design, right? All right, so you have to ask yourself, why do you want to program? And programming is hard. You have to spend a lot of time doing it. It's not something you can just do on a side. It's a set of skills that you have to continuously refine and continuously kind of practice. It's a little bit like with anything else, like, you know, it's like with running. Everybody can run, but to run really well, you have to kind of train. Every week you have to do a little bit of running. So here is the same. You can program in C++ because you had it last year, but to really program, you have to kind of refine your skills and do it. Do small problems all the time to kind of be better at it. So I'm kind of like a little bit of a soul searching here. I like it from both because it's kind of an artistic way of expressing yourself, but it's also an engineering task. You have to kind of, all the moving parts have to kind of work for the whole thing to work, right? So there is a creativity, but it's also an engineering. And that's why it's quite both exciting and hard because it's not just engineering and it's not just art. It's kind of both. All right, so how can you learn programming? By programming. Exactly. So that's the whole point, right? I cannot teach you how to program. We cannot just come here, you will sit here, and I will magically teach you how to program and go. Like, you have to do it yourself. You have to train it yourself, right? We cannot come here and by lecturing you, I cannot teach you how to ride a bicycle. Like, you have to ride a bicycle, right? So what we're trying to do is we're trying to make you kind of do stuff here to teach yourself, but don't expect that I will teach it to you, right? I can give you some hints and I can give you some examples, or I can answer questions, but I kind of cannot teach you how to program. Like, you have to learn it yourself. You have to teach it yourself. So there are some good strategies. So watching tutorials is good, reading documentations is good, doing it, right? And having some pet projects. So outside of the normal class, just pick something that interests you, that you want to do, and kind of use a new programming language to do that in that new programming language. So pick a problem, small problem that you, or small app that you want to have, and do it in a new language that you want to learn. All right, so what is Go? Go is a relatively young programming language done by old people. So they had a lot of experience developing programming languages, and they came up with the language which was specifically designed for large teams working at Google, and they were focusing on server-side processing, right? So what does it mean, server-side programming? Yep. Runs on the server, exactly. So it was not designed to be an application development language for end users, for desktops. It was designed for a server-side software which runs on servers, right? So they do have slightly different characteristics. So would Go be a perfect language to write games in? Not really. It was not designed to be used for graphics and for games. Is Go really good for networking applications? Yes, it is. Actually, it's one of the easiest and best languages to do network applications in because of a rich standard library and the networking kind of focus and all the concurrency patterns that it has. Is Go better than any other language? No, there is no best language. Like, different languages have strengths and weaknesses, right? And it's the same with Go. The main motivation for the language was the productivity of teams, of large-ish teams. So what does it mean? Well, it means several things, right? So first thing is, in a team you have people who are very good and not so good. So you need language which is not too hard, right? Rust, for example, is a very nice language, but it's quite hard and it only works with good people. Like, poor programmers can't really do Rust, right? So if you have a team and you say, let's use Rust for our team, you'll have people who are completely unproductive because they can't just do it. It's too hard for them, unless you have elite programmers in your team, right? On average teams, you will have good people and bad people, and you want something which works for both. So languages like C++, C, Rust, those are kind of hard languages. They don't work for everybody. Languages like Python, to some extent Java, they were designed to mesh it, to make it a bit easier for weaker programmers to be productive. Go is also on that scale, that it's very easy language and everybody can use it. Everybody can be productive in it. So that's one thing. The second thing is, with large teams and large projects, you have a lot of software to compile. So if you ever try to compile Linux kernel, or if you ever try to compile some big application in C or C++, you know you have to wait for the build to finish, right? Even in Java, if you have like a largish project and you want to build it, it takes time. So build times with Go are incredibly fast. You almost never wait for the build to do for large programs. They are really, really fast. Rust is also slow, right? Rust is very nice, but the build times for Rust are not that great. So build times, compile times for large projects, that was one of the options. And then maintainability. So having kind of a code which looks the same way and new people can come and read it and maintain it. It's one of the features of those languages which kind of pay attention. So for example, Python is really good at it because it forces people to use a certain structure, right? C++, it's not good at it because you can express the same thing on a million different ways. And each programmer may have a different way of capturing particular pattern or particular thing, right? And laying out your source code and so on and so forth is like very open, very elastic. In Go, it isn't. In Go, actually, if you put a brace in the wrong place, it's a compile time error. It's not formatting of the code error. It's a compile time error, right? So Go forces you to use a very standardized way of formatting your code and putting braces in certain places such that the code looks the same. You may hate it. You may say, yeah, but I don't like braces kind of this pattern. I want the braces different pattern. Tough luck. Go kind of forces you to use braces in kind of a Java style, not in C++ style, and that's it. You cannot go around it. In other programming languages, you may agree with the team to do this or that, and then everybody has a freedom. And then you use linter to enforce the rules. In Go, the linter and the compiler enforce the rules, and they are built into the language, right? So conformity of the source code was kind of an example. And they have achieved that by having kind of a simple language, a very rich standard library, and kind of integrated tool chain which enforces all those rules. So what are the main features? It's statically typed. What does it mean? What's the difference between statically typed language and dynamically typed language? What languages do you know? C++. Is C++ dynamically typed or statically typed? Statically typed. Okay. Python. Dynamic. JavaScript. Dynamic. Java. Static. So what's the difference? Yeah? Okay. Yeah, that's close. It's close. So So in some languages you have to declare it, right? So I have to say int I equals 10, right? So I was forced to say I is integer, right? Statically typed. Okay. In JavaScript, I would say var I equals 10, right? Dynamically, I don't know what I is, right? In Go, I can say I equals 10, and I haven't declared it yet, and I didn't set it's an integer, but it is an integer in Go, because I assigned an integer to it, and the type of I is already defined, right? So the difference is not necessarily what you have to do, but what happens behind the scene. So in statically typed languages, every variable has a well-defined type associated with that variable, right? So if I did that in Go, the deadline, and then I said I equals mama, right? The compiler will say, wait a minute. I was an integer. You cannot assign string to it, right? You're messing up the types. If I do this in JavaScript and then do this in JavaScript, JavaScript says, yeah, it's fine. You know, it was integer, but now it's a string, right? And if I do that in Python, Python will be happy as well. Python will say, it used to be an integer, now it's a bool, and then it's a string. It's okay, right? In statically typed languages, you cannot do that. You cannot change the type of the variable which was originally assigned to it. And in some languages, you are forced to declare it manually. But in some statically typed languages, the type system infers what is the type of the variable and keeps it through the life of the program. So in Go or in Haskell or even in C++, you know, in the modern C++, you have something called auto, right? So you don't say what it is. You say, let the compiler work it out. But once you declared I or declared a variable in C++, you cannot change its type. You cannot suddenly say it used to be integer, now it's a string, right? All right, so it's garbage collection. It has a garbage collector. What does that mean? Yep. Yep. So cleans up the memory which are occupied by unused variables, right? So what languages do you know which have garbage collection? Java, C#, Python, JavaScript. Which languages do you know which don't have garbage collector? C++, C, assembler, Rust. Those languages don't, right? What is the advantage and disadvantage of having a language without a garbage collector? Yep.
You know what you have more possibilities to do stuff if everything is on you.
That's right.
You have,
Yeah. That's right. So the advantage is you have full control of the memory management. You have to take care of all the allocations and deallocations. The disadvantage is you have responsibility for all the allocations and deallocations. There is no safety net. So if you forgot to release some resource, you will have a memory leak. And those bugs are kind of hard to track, right? So I'm not sure if you did experience memory leaks in your C++ programs, but I'm sure you did. I'm not sure if you experienced the segmentation faults in your C++ programs, but I'm sure you did. And it's not uncommon. It just happens. Like, it will happen to everybody. So, but the advantage is you have full control over the memory management, which means you can be very efficient and you can be very fast because you decide how to use the memory and you can optimize it for your use case. So if you're writing a game, if you have to process, 60 frames per second or 90 frames per second, then you have to be very tight You don't want a garbage collector to kick in and occupy your CPU cycles at random times, right? You want to schedule when the memory is released, when memory is allocated, because you're playing with the clock, right? But if you don't care about it, then garbage collection based languages are better because you don't kind of need to manage that. It is managed for you, and you will never have memory leaks because the system kind of manages for you, right? The system, the older systems were used to be not that efficient. The modern system, like a modern garbage collector in Java or in Go, they are really good. It really takes really good programmers to beat it, right? So if you're doing average things, you'll probably be actually better off using garbage collector than not using it. There are garbage collector systems on top of C++, so you can, for example, use managed memory in C++ as well. And C# is kind of an example where you can do both. You can manage memory by yourself, or you can let the system manage memory for you. All right, so third one, functional. That's kind of an ongoing debate. What does that mean? What functional language means? And Go is not kind of orthodox functional language, right? We just use it as a way of saying it's not really object-oriented like C++ is. It's more kind of like C, which is based on functions. So everything is a function, and not everything, but most things are functions, and functions are first type kind of objects and first type citizens in the language. So it's easy to express things and to compose functions, right? It's not functional in a sense of Haskell, but it's much more functional than Java or C++, because you do more compositions and you do more programming using functions. Concurrency. What does that mean? What is concurrency? Yeah. Yeah. So it has to do with doing things at the same time. What's the difference between concurrency and parallelism? So parallel program and concurrent program. What are the differences between those two? Yeah. So I have a parallel program and I have a concurrent program. What's the difference? What's the kind of the meaning? So which one? Yes. So yeah. So abstractly speaking, if I have a parallel program and I have only one CPU, then I have a parallel program on a single CPU? No. I need to have at least two CPUs to have parallelism, because parallel means they actually happen at the same time. Two things are happening at the same time, physically. Concurrent means they appear as if they are happening at the same time, but they can run on a single CPU. So I can have multiple threads which run concurrently on a single CPU because I'm doing time, multiplexing, right? So I run one thread a little bit, and then the next one a little bit, and then this one a little bit, and this one a little bit, and then for the user, it appears as if I have 4 threads, but in fact, I'm only running one at a time. But if I have multiple CPUs, then I have a true parallelism, right? So sometimes we say true, right? Because those terms, sometimes we kind of make them to mean kind of the same thing, but technically, parallel means you physically executing something at the same time, whereas concurrent means not necessarily. On the lowest level, on the operating system level, I might just have one CPU and I might just be executing one thing at a time, right? I still may want to have concurrency, right? Why? Well, because it's easier for me to organize my game. So let's say I'm writing a game and I have to take care of user input. I have to take care of the physics interactions of the objects that I have, and I have to render to the screen. So I have 3 tasks, right? It's much more logical for me to have 3 threads, each taking care of whatever needs to happen concurrently, even though my game runs on a single CPU, right? So when we program, we kind of don't really talk about parallelism that much because we using concurrency structures to pretend that we have multiple things to run concurrently, and then physically, when we actually deploy it and we have a multi-core machine, we can run it in parallel or not, right? But concurrency is useful even if we don't have a parallel hardware, right? There are parallel computers, and the parallel computers, they have multiple processing units and they execute things at the same time. So that's what we call a parallel computer. A parallel computer could be a GPU-based. GPU has physically multiple cores which run a lot of things at the same time. So typically for programming concurrency, we use a concept of a thread. So we have kind of a concept of execution pathway, which is separate from another execution pathway, right? So did you have operating systems? Or you have it now? You did? Yeah. Oh, really? That's not good. So you in operating system course, you will learn about threads, p-threads, right? Yeah. Okay, so BitSec had it. So those people are kind of a little bit ahead. They already know the concept of threads, right? For the rest of you, you just have to imagine that there is something like a thread, which is sort of like a function which runs and executes all the instructions in the function, and then there is another function which also runs and has all the instructions about it, and they kind of happen at the same time, right? Typically, you have a concept of a thread, operating system thread, which is like a separate process which runs its own execution, and then you have other ones which run their own execution. And on the operating system level, it's quite heavy. You can pretend that you have multiple lightweight threads running on a single process, and those are called sometimes green threads, like in Java lingo, or they are called Go routines in Go lingo, and other languages have similar concepts. So the idea is that sometimes it's more costly for you to spawn a new thread, physical thread, than to pretend that you have multiple things on a single process. It's more efficient just to pretend, not to use up the resources to allocate it and then deallocate it. It's just easier just to do that on a single thread, but have concurrency. So I can have multiple things appear to happen at the same time, but actually they run on a single process, right? So Go routines are kind of a mechanism to do that. Like if it's more efficient for spawning multiple things, Go will do that. But if you only have one CPU, Go will pretend that you have parallelism, but it will give you concurrency. Does it make sense? Abstractly speaking. All right. So we don't have classes in Go. There is no concept of a class, but there is a concept of an interface. So what languages do you know which have interfaces? Java. Good. What other languages do you know? Huh? So does C++ have interfaces? Yeah, C# has interfaces, but how about C++? So those of you who know Java or C#, how would you do that in C++? How would you have kind of a concept of an interface in C++? Huh? No?
What does C++ have that C doesn't? Classes? Oh, yeah.
Yeah.
There you go. Abstract classes.
So an abstract class which has virtual methods and no implementation, right? That is kind of like an interface, because then some different classes may implement this, and then you can always cast it to that base abstract class, right? So you kind of, I mean, C++ doesn't have a keyword interface, but it de facto has a concept of interfaces as well, right? So how can we have an interface in Go where we don't have classes, right? That's a bit weird. Go has structs, and structs are kind of like the object without any methods, right? And then you can attach methods to those structs. So you may kind of push the analogy saying, actually, Go has something similar to classes, because it has the structs, and the struct is like a C struct, but then you can attach methods to that struct, which is sort of like C++ attaching methods to the struct and just calling it a class, right? In fact, you can call struct in C++ and have methods in a struct as well. We tend not to do that this way, but it's actually legal to call a struct and have methods in the struct as well. But it doesn't have any inheritance, right? So do you know any other object-oriented language which doesn't have inheritance? Yeah, not really. Most do have it, right? But inheritance doesn't solve everything. So if you designing your class hierarchy or classes and you don't have inheritance, what can you use? Yeah.
You have like structs or something to go in and do attach the same functions you go to them.
Yeah, you can attach the same functions, so that's what interfaces help us to achieve. Yeah, but let's say I have a type of a person, and a person has name and surname and age. Okay, so I say I have a type which is a person, name, surname, age, and then I have a type which is a student, and student is a person, but also has a student ID. So if I have an inheritance, I have a base class which says person, name, surname, age, and then I have a subclass which says student is a person and has student ID. Easy, right? But now I don't have inheritance. So how can I do that? How would you do that? Yeah? Exactly. Exactly. So you will make a struct which is a person and say there is a struct called person. It has 3 fields. And now you will make a struct which is a student, and you will say student is also a person because it has a person inside it and a student ID, right? So you will compose. So composability is one of the solutions to inheritance in cases where there is no multiple inheritance, or in cases where you kind of don't want to mess up with deep nested inheritance hierarchies, right? So you just compose your types out of simpler types. So you can have then a student assistant, which is a student, right? Or you can have a teacher, which is a person and has some extra fields, and so on. So you build those primitive types first, and then you compose the more complex ones by composing them, right? Did you had UML diagrams in one of the courses? Yeah. So you remember the diamond operator? That's exactly what I'm talking about, right? And the diamond operator can be either black or empty, right? So you either do it by reference or by actually putting the data in your structure. Remember that? So that's how you do that in Go. You can do it either way. You can either compose your structs by the black diamond or by the empty diamond.
This is an okay, so that you have a person interface and you have a student interface inside that interface.
That's right. Yeah.
Like a list and a list and
Yeah. So then you kind of do it dot person dot something, right? Yeah. And that solves the problem of multiple inheritance because you have to specify which one you mean, right? Just by its syntax. All right, so that's a kind of a simple diagram of where Go came from. So Go is like 10 years old now. It was initially released in 2009. It kind of comes from directly from C, but it has some features which were developed from the Pascal kind of line of languages. And for CSP stands for concurrent sequential processes. It's a kind of a language for defining concurrency. It's a formal language for defining how multiple threads can kind of communicate with each other and run. So that was work done in 78. It's kind of amazing because so it's like 40 years now old, and we don't really know anything better after 40 years. Like this work, we still use it in all programming languages that have anything to do with concurrency. It's still the best way of formalizing kind of concurrency in programming languages. And then there was kind of a Squeak and new Squeak. When I was doing my studies, I actually learned Squeak. It's kind of a fun programming language. And when I was a student, we had to learn Pascal. So Pascal was as popular back in a day as Python is today, right? Everybody was learning Pascal, and we were doing everything in Pascal. So that was kind of came up with in 1970. I remember learning object-oriented Oberon and telling my brother that like this language is like the best in the world. It's gonna take over, and he was laughing at me, and he was right. Like nobody ever heard about Oberon, but at the time it had a very nice kind of a concept built into the language. So I love that. Again, when I was a student, I learned that one too. Learning multiple programming languages kind of helps you to build internally some concepts in your head to be able to express yourself in different languages, right? So I do encourage you to learn other programming languages, even if you're not gonna use them every day, just to learn how they work, how they abstract the problem into particular way of structuring it, because it will kind of make you a better programmer for other languages. All right, so at that point, last time we were discussing Go tour. So if you go tour.golang.org, it has an interactive tutorial, and it's gonna take you, I don't know, maybe 15 minutes, 20 minutes to go through all the basics of the language, right? It's a very easy way of learning the basics, and what we kind of did that last time. So yeah, let's have a break. You don't have to do it. You can do it later after the lecture. So let's have a break now. And what we did last time, which we'll do later, is you will ask questions which are not covered in the tutorial. And one of the questions last year was, how can you create a slice in a single step? How can you, not using make, but how can you have a particular slice which is initialized and created in a single step instead of two lines, right? So that was one of the questions which we had last year. This year you may have some different ones. So yeah, 15 minutes break, and we meet 9:45. Just give me a second. All right, any questions so far? Have you started doing the tour? Who started doing the tour? Easy? Yeah, I think the basics are easy, and then once you get to like slices and pointers and so on, it gets a little bit harder. But you know, it's relatively easy. Like in a day or two, you will have it covered. The language is actually really small. What is big is the standard libraries. So there is a lot of libraries with a lot of functionality. So that part is big, but that part you don't need to memorize because you can always look it up using the Go documentation. What you need to memorize is like the basic things, and the basic things are kind of simple. Func, you know, the types, the syntax, that variables come first, type comes second, and you always declare things by naming them and then putting the types. We will cover it. So we will cover it, most of the more harder things later. The basic things you have to do on your own because they are just easy. So if you will have any questions, just post them on the issue tracker or just ask in the class. All right, so let's do some simple things. So we did discuss that already to some extent. This is kind of a summary for all the benefits of using Go. It has a relatively large ecosystem, very big support libraries. So that's what annoys me about Rust a little bit. That I mean, it's like also a strength because all the functionality is provided by different ways by different people. But then you have difficulty who maintains it and you know what level it is and backwards compatibility and so on. Here, all the things that you really need to program are in the standard libraries. So you don't really need to use external dependencies for most of your work, right? And that's a good thing for software that you want to maintain for a long time. It has relatively good abstractions, not as good as in Rust or in Haskell, but yeah, for simple things it works pretty well. It's very easy to maintain. It has all the tooling and maintenance kind of support built in, which is great. Once you get used to it, you go back to C++ and then you're like, why I don't have a linter built in? Why all the things are not in there? Like, why can I pull external dependencies, right? You sort of expect it from a modern language to have all those things kind of built in. And the modern languages, they do, like Rust has it, Haskell has it. So what is linter? You will know what linter is.
You don't love it.
That's right. So it basically goes over your source code and it highlights the violations against the coding conventions and some violations that are like you didn't put a comment in or you naming variables the wrong way, because in Go you have to use camel case. If you're not using camel case, it will kind of complain. What's camel case? Yeah. Capital, yeah. So what's the other way of doing those namings? Using underscore. How is it called? So one is called camel case, the other one is? How? Pascal? Snake? Yeah. In Go you have to use camel case. In C++ and in Rust, we tend to use underscores to separate different words in our names, but you can do whatever you want, or whatever you agree with the team. Here you have to use kind of camel case, otherwise the linter will throw fits. All right, so I also did a little bit of a check between this year and last year. and you can browse the statistics. So there are different ways of comparing programming languages. So for example, Redmank takes GitHub as the main source of data, and basically checks how many projects are written in a given language and how many questions are asked on, or how many tags are based on questions on Stack Overflow, right? And then the more you have, the more the language is sort of used or popular or whatever the metric you can think, right? Because based on those two metrics. So for example, WebAssembly is not very popular yet, neither on GitHub or on Stack Overflow, but languages like Haskell, C, C#, JavaScript, Java are kind of really on top, right? So that's one way of looking at the programming language. What else? These guys are doing also, an analysis, and they take different metrics into account, and they kind of create a list based on those metrics, on the ratings that they use, and according to their ratings, Java is the most popular, and C is number 2, right? Python is kind of growing, and then Go is like halfway through the second 10. You know, for you, how important is that? Well, I mean, you will be looking for jobs in a few years' time. So knowing which languages kind of are very popular gives you some indication. Knowing which languages are not very popular also gives you some indication, because that means not a lot of people are using them. And if the team needs those languages, then it's kind of good to find a job, right? So what is the most paid programming language in US from last year? Can you guess? Yeah? No. It's not Java, not MATLAB. It's not C#. It's not Python. It's not C. And it's not COBOL. It's not Go. It's not Rust. It's not Kotlin. It's not Assembler. It's not Rust. Huh? No. No. So all those languages, they have a lot of people. So which means there is a lot of potential candidates for the job, which means that the salary goes down because you have competition, right? Instead of paying more, I can pay less because I have to choose from. So what languages I cannot really choose from? COBOL? No. But it is quite high up there, right? So there is a functional language developed by Microsoft. I give you a hint. And it has sharp in the name. It's not C#. C# is not functional. Huh? F#. You've heard about this language? So F# is a functional language developed by Microsoft, and it runs on .NET, and it's very similar to Haskell or Scala or some other functional languages. But it works on .NET, so you can mix it with other .NET technologies. And not a lot of programmers are skilled to use that language, but different labs or different companies need programmers in F#. And F# is kind of the most paid salary-wise programming job you can get in US at the moment, right? All right, so we kind of running out of time a little bit. So we've covered that already as well. We will do that on the next session. We will use some command line tools to format your code and to fix kind of coding bugs and so on. I'm just kind of giving you a list of all the Go commands which you can do on your source code that you will kind of use frequently in this course. So formatting your code to align properly to the standard coding conventions. Go fix will go through the typical errors that you might have in your source code. A linter, vetting also, it's kind of like a fix. and then testing framework and documentation, which GoDoc is like Doxygen. It kind of extracts all the comments from your code and generates the documentation. So now you have the list of all the little things. So try to do that for the next session, and then the hard ones which you cannot do, we will do in the session, and we can discuss with you how to do kind of a more advanced things. But try to go through the Go tour and try to start on doing the little like hello world type of exercises. You can either use the slides or you can use the list which is in the on the wiki, the programming tasks. All right, so thank you very much. Just let me stop.
Oh, did you figure out this decay problem?